welcome to Basic to Arduino. Today we will do to blink an LED. The component needed to do this is the breadboard, male-to-male wire, Arduino, upload cable, single LED, and 330 ohm resistor. So before we start, let's learn the basic of breadboard. So for example, this pin right here should be pin 1A. The first 5 pins A, B, C, D, and E of any row are all connected to each other. There is a little wire that runs underneath the breadboard that connect each one of these pins, and it's also the same for column F, G, H, I, and J. Row and column on the side work a little bit differently. Every single pin in this positive column is connected to every single other pin, and every single pin in this negative column is connected to every single other pin, and it works the same way on the other side of the breadboard.
As you can see, the LED has two leads. The longer one is the positive one, and the shorter one is the negative one. Take the longer lead and plug that into pin 1E, then take the shorter one and plug that into pin 2E, like so. Now take a black wire and find either one of the two pins labeled G and D on the left-hand side of the Arduino, and plug this wire into one of them. Next, take the other end of the wire and plug that into the negative column on the breadboard. Now take a green wire and plug one end into pin 9 on the right-hand side of the Arduino, and then take the other end and plug that into pin 1A on the breadboard. Now, take your resistor, which should be 330 ohms, and bend it until you have a U shape, like this. And now take one end and plug it into pin 2A, and then take the other end and plug it anywhere on the negative column of your breadboard. Now, download the sketch blink.ino attached to this video and open it in Arduino. The first thing you should know about Arduino is that it is built around two functions, void setup and void loop. These are simply places to put code. Code you put in setup only runs once, while code you put in loop will run repeatedly until the Arduino is disconnected from a power source. Let's look at the first line in setup, the pin mode function. Before we start using pins on the Arduino, we need to tell the Arduino which pins we will be using and how we will be using them. In this sketch, we use the pin mode function to tell the Arduino that pin 9, which is connected to our LED on the breadboard, will be used as an output. This will happen once at the start of the program when the Arduino is powered on. The next important line is in loop, the digital write function. Digital write allows us to send a signal out of a pin that is either 5 volts or 0 volts. To use this function, we specify the pin and then what we want it to do. It can either become high, meaning that it will output 5 volts, or low, meaning that it will output 0 volts. The pin will stay at high or low until we tell it to do otherwise with code. We start the loop by writing pin 9 high. Since the wire from pin 9 is connected to the LED, it will turn on. In the next line, we pause the entire program for 1,000 milliseconds, or 1 second, by writing delay 1000, so the LED stays on for 1 second. After this, we turn the LED off by using the same digital write command, but this time with low. And we also use one more delay to make the LED stay off for 1 second. When the program reaches the end of the loop, it goes right back to the beginning of the loop and runs all the code in loop again. This will make the LED turn on for 1 second and then turn off for 1 second continuously until the Arduino is disconnected from power. After downloading the code, our LED is started to blink. It turns on for 1 second and then turns off for 1 second.